These are your section 1.5 notes, solving inequalities. So now the section number will match the actual section number of your book and on your online text. So to solve inequalities, you're going to pretty much use the same method as we do to solve equations. You're going to use inverse operations to isolate the variable. Since it's now an inequality, no longer do you have just one solution where maybe your solution was x is equal to 5. Now we'll either have x is less than 5, so there's a lot of variable values there, an infinite supply of values that are less than 5. X could be greater than 5. Again, an infinite supply of numbers and solutions. And then sometimes we even include the 5 in that. By putting a line underneath there, now we're saying less than or equal to, greater than or equal to 5. So it's like a little part of the equal sign means we include 5. So you're going to use inverse operations to get the variable by itself. One of the things that happens is that when you multiply or divide an inequality, when you multiply to solve with inverse operations by a negative number, it flips the inequality. It changes the value. And I can explain this a little bit more tomorrow when we're going over the homework. But what happens is when you multiply by a negative number, it changes the value of that number, and a number that was positive now turns negative. And so what you've just done is taken a number that was maybe on the right-hand side of the number line greater than 0 and made it less than 0. Or maybe you took a negative number and made it positive. So either case, it changes, it goes over the other side, the opposite side of a number line, and so it changes its value. So you have to flip the inequality. A less than will become a greater than, or a greater than will become a less than, only when you multiply or divide by negative numbers. I find that solving inequalities, it's much easier to keep the variable or get the variable on the left-hand side. Then it's easy to actually understand the inequality. It sort of points to the solutions. When we're solving equations, I could solve where the variable was x equals 3 or 3 equals x, and it really didn't matter. But when you're talking about inequalities, it's a lot easier to understand when the variable's on the left. You usually have a range of solutions, and so more than one answer. I just talked about that using the example of 5. And so what we do is we draw a visual aid. Anytime we have inequalities, we always draw a number line. It's a picture. It helps us understand the solutions. Then we interpret that number line. So the number line is part of your work. And then you interpret that number line. And you're going to write your solutions 2 different ways. Set builder and interval notation. So I'm going to show you both of those, or all 3 of those. The number line, set builder, and interval notations on the next slide. So I'm just going to stick with the value of 3 every single time, positive 3. So on a number line, let's go ahead and we can put 4 number lines right on our work here. So to show a number line with solution 3, you can put 3 right in the middle. That's fine. I really don't need to know all the other numbers. And so this is not going to change from one number line to the next. So those are our 4 solutions where it's 3. But we could be less than 3, we could be less than or equal to 3, we can be greater than 3, and we can be greater than or equal to 3. I can even add, just for review, we did this one already. When x is equal to 3, it's just a circle at 3. Okay, so x less than 3 are all the numbers that are less than 3. So if we go up here to the number line, 2 is less than 3, 1, 0, -1, -2, -0.5, -1,000,000. And so what happens is these are all the values less than 3. And so when we put all those numbers, every number, every fraction, every decimal, less than 3 on the number line, it gets really crowded. And so these are all individual points, forever, never, never. And so what we do in math is we just simply draw a line. And that's our mathematical way of saying, okay, we're not skipping anybody. We're including all the fractions, all the decimals, rational, irrational numbers less than 3. I said 2, but 2.5 is less than 3. 2.9 is less than 3. 2.99, 2.999999999. And so another thing we do in math is I'd keep getting closer and closer to 3. So a way to show whether we're going to include 3 or not is we use an open and closed circle. So this would be an open circle. An open circle is for less than and for greater than. Does not include the number. So by making it an open circle, we're basically saying we're getting really close to 3 but not including it. If you look at my example here for x equals 3, it was a closed circle. That's all you had. So we're kind of doing the opposite of that. It does not equal 3. Values of 3 is not less than 3. 3 is equal to 3. For set builder notation, you just use those little squiggly lines. And so what we say are the solutions are x such that x is less than 3. You basically take the solution, you put a fancy little x on a line out in front of it. That's just fancy mathematical language. The first x is saying the solution is x. Now I'm going to describe the solution to you. Such that is the line, or when. So it's a mathematical abbreviation. So the answer is x when x is less than 3. Okay, I want you to get used to that. I don't want you to, we'll sometimes do it and sometimes we'll just get rid of that part, but I usually practice that because if you see it on a test, an SAT or an ACT or whatever test you're taking, it won't freak you out. You know that it's just a mathematical symbol. So for interval notation, in interval you're giving a value, you're giving a range. And so you're always giving the range from left to right. So you're going to give your left boundary and then your right boundary. And your left and right boundaries could be parentheses or braces or brackets. Sorry, those are brackets. And you could use one or the other. So the leftmost boundary of these solutions is negative infinity. This goes on and on and on to negative infinity. So the leftmost number on that number line is negative infinity all the way into 3. So where do the solutions begin and where do they end? They begin at negative infinity and they end at 3. Now you can't equal negative infinity. There's no such place. You can't be negative infinity. It's just a place that we approach. It's not really a number. So that's going to be a parenthesis. And then in this particular case, we are not including 3 as well. So that's also going to be a parenthesis. So for interval notation, parentheses are for less than and for greater than, kind of like the open circle. The braces, keep calling them the wrong thing, are when they equal the value. So you can actually have a mismatch. You can have 2 parentheses, you can have 2 brackets, you can have a parenthesis bracket or a bracket parenthesis. Those are all interval notation symbols. Again, pretty funky looking. And so if you saw this prior to this lesson, you might think it's an ordered pair. Or if you see a brace with a parenthesis, that looks a little odd and it can be scary. So I don't want you to be intimidated by that. Let's go on to the next one. X less than or equal to 3. Well, it's all the values that we had from before, but then we're going to pick up 3. So we're going to include 3. So by filling in the circle, that tells us that we're including 3. So the only thing that's going to change in our set builder, we're going to say that the answer is x when, vertical line, x is less than or equal to 3 with our braces. And for our interval notation, we are still talking about the numbers from negative infinity all the way to 3. But this time can't really equal negative infinity, so parenthesis, but we're equaling 3, so it's going to be a bracket. All right, next example, x greater than 3. Well, that would be all of these numbers, 4, 5, 6, 7, 8, 9, 10, all the way to positive infinity. So we draw a solid line saying we're including all of them. 3.01, 3.001, 3.00001 is greater than 3. So we're going to put an open circle at 3 saying every number really close to 3 but not including 3. That's our mathematical symbol. Set builder, x such that x is greater than 3. And for our interval notation, our range of solutions are from 3 all the way to positive infinity. We do not equal 3 And we do not equal infinity because you can't. So double parentheses. And last example, x greater than or equal to 3 would be a closed circle at 3, shaded to the right. And so what you're doing is you're drawing a picture. If you can locate a number anywhere in the purple region there, it's a solution. I can draw you a picture. I can't list them all because there's too many. There's an infinite supply. X, when or such that x is greater than or equal to 3. My solutions are again from 3 all the way to positive infinity. So I'm giving an interval. I'm saying between 3 and positive infinity, including 3, not including positive infinity. So that's where you get your brace and your parenthesis. Okay, let's try a couple and then we'll call it good. So we're going to solve these. We're going to put them on a number line, and then we're going to give both representations of the solutions just to practice. So right now, if this was an equation, 2x minus 5 less than 6x plus 3, if this was just an equation, I would be tempted to move the 2x over to the 6x. But because we're dealing with an actual inequality, I said in the beginning, it's best to have your variable to the left. So I'm going to subtract 6x from both sides. Even though it's going to make my variable negative, I'd rather have the variable to the left. So negative 4x minus 5 less than 3. I'm going to add 5 to both sides using inverse operations. Negative 4x less than 8. I'm going to divide by a negative 4, and when I divide by a negative 4, that positive 8 that used to be on the right-hand side of the number line is now going to end up being a negative on the left-hand side. So when we divide by a negative, I have to flip my inequality. It used to be less than, now it's greater than negative 2. So there's my solution. To get my set builder, I already have it written down. I'm going to squeeze in my x in front in my line. There's my set builder notation. I'm going to draw the number line because I feel like to get intervals, sometimes it's easier to see it on the number line first. On the number line, greater than negative 2, open at negative 2. And then what I like about having the variable to the left, if you can look at your inequality, it almost serves as an arrow pointing the direction. These are all the values greater than negative 2. When it's written backwards, it's harder to see. So having the variable on the left-hand side is helpful. Make sure I can tell that you actually shade so I can see it. You can even get squiggly or go above the line. My interval notation, my range of values are from negative 2 to positive infinity. It does not include negative 2, and it can't include positive infinity. So double parentheses there. Last example. For this one, I'm going to subtract 1 from both sides. Negative 6x greater than or equal to 36. I'm going to divide by a negative 6. Again, I'm dividing by a negative, so my inequality is going to flip. I'm left with x less than or equal to negative 6. So I flipped my inequality. To write my set builder, I can just throw a line and an x out in front, x such that x is less than or equal to 6. I'm going to draw my number line, put negative 6 on the line. It's going to be a closed circle at negative 6 because we're going to include it. Again, my variable is on the left-hand side, so my inequality is actually serving as an arrow pointing to my solutions. These are all the values less than negative 6. And for my interval notation, my solutions are from negative infinity to negative 6. It cannot be negative infinity, so parenthesis, and we are including negative 6, so bracket. All right, so on your own, I'd like you to explain when to use parentheses and when to use the brace in solutions of interval notation, and I need you to solve this inequality. I'd like it graphed on the number line, and then I'm going to let you choose whether you want to use set builder notation or interval notation as far as your solution set. Good luck.